Okay, hi everyone, I am here. This is Raj Develop, and I am uh, in the last video we cover or we learn the array, vector, and hash map tree, slicer, etc. So today we will go through threads. So um, yeah, let's start our um learning session. I am also learning. The fact is I am also learning, and what I don't know, I just google it, right? And I found that, and try to explain myself. And also, if you have or get a benefit from the learning, and I also give the um, this is not the Rust book, right? This is 100 exercise to Rust learning. That means this is just like a short syllabus. So I am also sharing the knowledge and the resource with you guys, so that I am learning, and you also can be benefited, right? So today topic is threads. So let's jump into the threads. So I previously I built I learn about threads in other language, so I will use that expertise on this Rust, right? So first is thread is use the std thread module for message parsing using channel, share state, use arc, mutex, read, write, lock, send, sync, trade, encoder, concurrency, genesis, right? So in OS, threads are used like that, and this is the core concept. And first we have to understand, so how these uh, threads came in this world, why we need threads, right? So first we need concurrency, right? From concurrency there we get four parts. That is, thread is our system part, right? Our system part, and that means in our machine, the hardware level uh, system is called thread, and we use um, thread to do tasks simultaneously. And I will go through the system, total system. We first have to understand the concurrency. So concurrency means uh, do task simultaneously or parallelly at a time. So that's why we need some portion, right? We need threads, async await, message parsing, share memory for concurrency, right? For concurrency. Okay, that is great. We need four part in concurrency. Thread is the part we will go through this part. And yes, you can see we have three tasks. We schedule it and pass two different threads, right? So first we will go to through concurrency, then we will deep dive into uh, other parts. So first we have to understand what is concurrency. Concurrency is efficiently waiting for show things while keep my program responsive, managing and multiple ongoing tasks, handling input output, waiting efficient, right? That is the fact. And now how to create threads to run multiple piece of code at the same time. This is the fact, that at the same time how we can use or create multiple thread multiple piece of code that can run in multiple thread, right? Sync and send rate, blast concurrency gradually to use identify run those important part called threads, right? So we are combining those part and we get called thread. That means if we go through, we here we combined some parts, and from this combination we get some outcome that is called thread. Overall we call it thread, right? So I understand this part. If you have any question you can ask me. I will try to answer from this part, right? So that will increase my knowledge. So I design a let's say I design a I draw a pattern. Here you can see A B C D. We need one. So we are struggling with problem statement, or we will go through the problem statement why we need what problem thread concurrency face. First we have to understand what problem concurrency face. So concurrency face mostly, let's say you have 4 guys, okay, 4 person using one variable or one thing. Now if this guy want to change this, let's say you are this guy know it have 5 in the box, but in the meantime this a came in the box and changed the variable. That means the variable is changed. So now the problem is what the outcome should came out, it just showing wrong things, right? Because the variable has changed, right? That is a loop. So let's say okay, here you can see we create new spoon thread that is okay for concurrency. We use spooner, right, in Rust. You can see, okay, here you can see in Rust we use spooner for concurrency. Create thread, we can use a thread spooner for thread or native for std. That means we can use spooner for concurrency, create concurrency in Rust, and sorry, create thread. I just mistakenly saying we just if we want to create thread we use spooner. Here what the fork mean, that is similar to fork is similar to spooner. So fork means we have two part, one is parents and another is children. Think like we have two part, one is parents in the program and another is children. Now we just stamp it with a fork so that it can't move, or it can go, let's say it can go parallelly, right? So we just here we just lock with fork. That is the main understanding. I as much as I can understand. So now this is the short understanding of concurrency And but in the Rust we are giving much value to, let's say we are giving, we will learn today is about thread. So yeah, we will understand the thread concept and where we can use this thread. And let's jump into the docs. So why I am using this documentation? Because if you want to be a senior developer, once upon a time one of my um, one of my gurus said that if you want to become someone, then you have to act like someone. So you first, if you want to be seniors, then you have to act like seniors. So what seniors do if they want to learn something? First they just open a, let's say, documentation and go through that documentation. What we are doing right now, that is the process. So what is thread? So that Rust big problem is fearless concurrency. Okay, make it easier to write safe concurrency problem. We haven't seen much that yet. All the work we done so far has been single threaded. Time to change that. That means all the topic we just learn, they are single threaded. Now we will multi-thread it. In the chapter we will multi-threaded, and we optional touch most Rust core concurrency feature. Okay, Rust core concurrency feature is how to create thread, how to pass message using channel, and share state using arch mutex, and read log, send and sync thread in core uh, Rust concurrency. So yeah, let's go through this documentation now. Okay, let's start. What is, here is the, okay, what is thread? Thread is a execution context managed by the underlying operating system. Okay, that means a thread is a executional, a thread is executional body, right? Okay, okay, so send to back, send to back, sorry, send to back. Okay, lock code, now we have to lock it down. Okay, so right, thread is a executioner, that is a execution context managed by the underlying operating system, right? We understand this. A single process can manage multiple thread. Okay, those threads share same memory space, while um, means they can access same data. So what we just find out, a single process. So we find out single process. We will lock down the keyword, right? What is single process? So okay, so single process, and single process and multiple threads, can manage multiple threads. Okay, multiple threads, and uh, those threads share the same memory space. The same memory space, share memory space. Okay, we find another word, that is share same memory. Okay, so we find three word, that is a single process can use multiple thread, and they can share memory, right? Okay, which means they can access same data. That means they can access same data. Thread are logically constrained. In the end, you can only run by set of instruction at a time on CPU core. The physical execution unit, since they can be many more thread than there are CPU cores. That means we can have many many okay, sorry, we have many thread than the CPU cores. You can okay, if I search, let's say, and core and thread in Ryzen Intel, Intel Intel, 8 sorry 808 uh, CO core i9. Okay, so here you can say see, we have in core i9 we have 24 core and 32 threads. That means we have uh, more core than the we have more thread than the core, right? So that is why when we schedule operating system schedule it in the change of um, deciding which thread to run and any given time, partition CPU time among them, max throughput and responsiveness, right? That means we can use multiple thread to increase responsiveness and maximal output. So here you can see okay, here you can see here you can see we will mm, use thread, right? And here it will print. Let's see what is going on in this code. Okay, so if I use let's say 3 second, so what will happen? Okay, you can see. So we have um, we have a thread that is slept for uh, 2 second. After 2 second it uh, arrived or it called, and that is how it working, right? So that means the thread is active every 2 seconds, right? Okay, I understand that. That means std thread standard library provide module thread that allow you to create a manage thread. Okay, spooner. Okay, right. What spooner do? You can use a thread spooner to create new thread and execute code of them, right? So here you can see okay, here you can see we are using spooner, but in the C they are using fork. So why we use spooner? To create new thread we use spooner word, right? So that is the core concept of spooner. Now what we understand from this part is yeah, okay, so You can use, okay, we can use spooner. So in this execution program, you will see many thread. Okay, we will see what is going on, right? Th- that is the fun with Rust. Okay, so let's first close it down. So we are using spooner, and in the spooner we have a loop, which loop have a thread which is sleep for 1 second, right? And hello for from a thread, and we have another loop that is not in the spooner. That means it is our main thread, right? Main thread. So what is going on, this thread will sleep for 2 seconds and print hello from the main thread. That means if we go through this code, that will not execute, it will execute, right? We can use okay, this, and we can use Rust. Okay, let's see what's happened. It will wait, fast this code will execute, and then it will execute. Let's see what happened. Okay, 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 okay. So that means what the fuck is this? Hello, let handle. What the fuck is this? I didn't understand what is going on. So I didn't understand this part, right? So if this, okay, I understand this part, the duration is, if two duration are same, which will execute first? Let's see. Okay, okay, okay. Now you can see, if the two execution time is similar, then it will execute this, right? But on the other hand, if we have execution time, lesser execution time in this, that will first. Okay, right, right. Okay, okay. We have to learn lots of things from, there is lots of thing to learn, right? So let's see what is going on in the code. Okay, there when the main thread finish, the overall ex process will exist. Okay, a spooner thread will continue running until it finish or main thread. Okay, okay, okay. That means a spooner will just like a, let's say it is let's say it is, a spooner is like a guard, like this is our guard, and this is called Superman. Okay. Huh. Okay, this is our guard. He is spooner, his name is Spawn. Spooner. So what he do, guard, GARD, so okay, let's, I have to GARDE. Okay, right. Alright. So this is the guard, which is spooner. What he do, he just okay, stop. he he just said that uh, if you if your let's say the program is not ended, right? If the program is not ended, in here you can see, oh, sorry, okay, here you can see we execute this program in Rust. So according to the ownership model, after executing a program, it uh, delete or it destroyed from memory. But in here what we are seeing that um, we use spooner. So spooner is our security guard. Like, this is our spooner, this is our security guard. Now this security guard will say, oh, the system is execute the main part, but we have another part that hasn't execute. That means we can't uh, let's say we can't get out from the main function, right? So that's why this spooner helping this code to live in this main function. Okay, I understand that. Okay, it is clear from my side. That's why this part is not dying, right? This part is not dying. Okay, right. Yeah, we understand that now. We can use this thread part. Okay, okay, now we won't use loop. Let's say okay, we will use uh, 5-second delay. Let's say what's happened. Okay, thread, 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 thread. Now this has been stopped, right? This has been stopped for 5 seconds, and after 5 seconds it will restart, right? What is going on? Let's see. Okay. Okay, so what is going on here? It will, our threads sleep for 5 seconds. In the meantime, we are printing this for 4 seconds. Now it has been slept for 5 seconds. Right. If we want to print it out, let's say print the main thread. Okay, we print the main thread. We will print it. What will happen? Let's see what happened here. Okay, thread, 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 thread. Okay, hello from the main thread. Okay, that means we execute, and after the execution of this line, this piece of line, the main function has done, and it is out of the memory, right? Okay, I understand that. What is going on? We use sleep keyword. So after 5 seconds this thread will sleep, and here we use spooner. After 5 seconds it just it was waiting for the main thread, right, for the main thread. So in the meantime we just print it, right? So yeah, so we see the spooner, why we use spooner. So here the spooner, to create new thread, we know that. And now we will use join. Let's see what it used for. We can also wait for the spooner thread to finish by calling the join method on um, on the join handle the spooner return. Okay, we can also wait for spooner thread to finish by calling the join. Okay, we are using spooner thread to finish by the join method. Let's see what is happening in here. In the example, the main thread will wait for the spooner thread to finish before this has execute from the synchronize between two thread. You are okay. Let's see what is happening right now. Okay, so what they are saying that if we use join, what will happen? So what do you think, what will happen if we use join thread? Hello from a thread, right? So we will use Rust icon here. Let's see what happened. Hello from thread. So handle unwrap. So why we need join? Let's ask AI. I don't understand this part. That is the real use case of AI, I think so. It just I don't understand. I don't understand this part. Yeah, RT. Yeah, RT. Okay. Join block is calling thread here. Okay, so here is this part is clear for from us. We are creating a new thread, okay, with spooner keyword, and spooner return a join handler. Okay, what and handle that allow you to interact with thread later, particularly to wait for the finish. Okay, join block the calling thread here, the main thread, until the thread associate with handle terminal. While join is called, the main thread stop executing further code. Wait once the spooner thread finish, and join thread return a result, right? Error or okay. In your example, spooner thread is just print a message then return. So join dot unwrap will return. Okay, why is join important? When the main thread exists, the entire process main thread exist. When the main thread exists, exit, the entire process terminated, and all other threads are immediately killed, even if they haven't finished their work. So without join, the spooner thread might not get a chance to run completely before the program exit. Okay, so that is clear. Let's see what happened if we don't use this line of code. That is, we if we don't join, what happened in this line code. If it don't print, we just understand that this part of the code help to print or to execute the thread. Okay, let's go through. Okay, now you can see what is going on. We have that thread. If we print sorry, if we print this, okay, we should print it. Print we are printing pri and then printing this. Okay, we are printing this. That means in this part this is not executing, because we are executing line by line, right? In Rust we execute line by line. Now the problem is, if we just execute and destroy the main function, and it will what will happen, that in the let's say thread, in the main thread, the task will not execute it. So that's why we need this join. Now it will execute, right? Because we are saying that look, the compiler, look compiler, we have spooner thread and we are joining this spooner thread. So if this thread is not executed, then you have to wait for the execution. Okay, yeah, this is the main this is the call, right? Okay, so great. So next we should proceed next. So what we learn from this thread part, we learn if we want to create thread, we should use if we want to use thread, we have to use standard library thread module. And if we want to create a thread, then we have to use spooner. And another thing we understand that if we use thread, okay, if we create a thread and let's say we have two piece of code, and that will execute, that will take 5 seconds to execute. In the meantime our thread will run, right? Another core thing we understand, join. So what join do, right? What join do? Okay, thread, okay. Right, what join do? Okay, okay, so let's find out. Okay, I think that is okay. So okay, right, join, what join do here? Okay, Control G, right? So right, okay, join, join, join. Join. Okay, we use join here. Okay, uh, okay, we should go next. Static, right? Why we use this static? If you try to borrow a slicer from the vector previous exercise, you probably got compile error that look like this. Previously we have this kind of compile error. V does not live long enough. That means what we are doing, we are passing a vector, we are passing a vector, we are passing a vector in the function, and we return a integer, right? So in this vector, what we have a slicer, right? We have a slicer, no, we have a slicer, and in the next line we have created a thread, right? Now they are saying that we are using this vector, but that vector is borrowed from the static. V is dropped here while the borrow. That means argument require vector. Where we need vector, here we want vector, right? Name V is declared here. Okay, V we declare this vector in here, and what we are saying that in the right the vector splice pointer. So splice pointer, what is going on? Okay, we will spread it out, and left dot iterate sum. So the argument trigger V is borrow. So static, it does not mean static. For static, it does not mean the lifetime is lifetime is a special special lifetime. Static lifetime is a special lifetime in Rust. That means what happened, let's say, that means okay, static lifetime is a special lifetime in Rust, and it means the value will be valid for entire duration of the program. That means we are using this vector, sorry, variable, and this variable, what we use this variable in blinding V declare here. Okay, left okay, borrow value does not live long enough, right? And we are using, okay, let me give a second. Okay, detach thread. So thread. Do you understand what is going on this code? I understand this part. We use static. This is the static uh, keyword, and we use this static keyword okay. Vector does not live long enough, right? um, okay, that means we use this vector, but that is not live long enough. That's why use static for lifetime. When we use this static lifetime, the this value will live from for the end of the entire program, right? Okay, so let's see detach thread. Let's see detach thread. I think okay, detach thread. In this thread, what is going on? Let's see what is going on. Okay. mm, uh, okay, no function main was detached. Okay, we don't have. Okay, I think okay. And that is function, right? So we have function. Okay, that is, I think, yeah, we have main and main. We have okay, here we have double loop, right? That means nested thread. Here we have nested thread. Okay, in this example, first will turn children thread, print the message every second. Okay, the first thread will finish and exit when the and that happen. The children thread will continue running for as long as it over process run. Okay, Rust lingo, we say that the children thread has outlived the parent. That means our children is living inside this thread, right? Okay, okay, okay. But from this example, I don't understand if that is execute. That should be there, right? That should be there. Okay, let's run it again. Okay, okay, okay. What we are sending? Okay. Sleep thread. That is the problem, I think. The continue running as long as the process is running. The Rust lingo, we say that the children thread is outlived in parent. Okay. Static life, since spooner thread can outlive the thread that spooner okay spooned it, right? Since a spooner thread can outlive the thread the spooned its parent thread, right? Run until the program exists. This is the core of static lifetime, right? Why we need static lifetime? That is why we need static lifetime, right? Okay. Static lifetime. Okay. It must not borrow any value might be dropped before the program exists. Violate this consistent work exposed to user after being bugged, right? That is why std thread spooner sign require that the closer pass to the it has the static lifetime, right? It must not borrow any value that might be dropped before the program exist exit uh, ex, ex, exit. Okay. um, okay, now what this line is showing us, that is showing us let's see. um, so we are using special thread, right? Mm, okay. Okay, so you must not borrow any value that might be dropped before the program exit. Violating this constant word expose us to use after being bug. Okay, after a free bug, right? This is why std thread spooner signature require that closer to pass to it has the static that will. Okay, that means if we use if we use um, spooner thread, we should make it clear that this program will live long enough, right? So that is the core of a lifetime. Okay, static lifetime. Okay. Okay, static lifetime. Okay, right, so we have found some point, and I think static, that's why we should understand about static lifetime in thread. That is too important for us, because without static lifetime the program will be ghost program. It will be like ghost program, and that is not good for that will give us an error, right? So if we don't want to let's say, if we don't want to face errors, then we should, okay, we should use static lifetime. Okay, I understand this part. And if we don't use static is not just about referencing, right? All the values Rust have a lifetime, um, not just reference a particular a type that owns data like vector or a string satisfied the static constraint. If you own it, you can keep working with it for a long as long you want. When after the Facebook that originally create, okay, the sorry what I just speak about. So if even after the function that originally create it has returned, okay, a type that own its data, okay, like a vector or a string satisfy the static constraint. If you own it, okay, if I own it, you can keep working with it for as long as you want, okay. That means if I own it, I can use it as much as I want, even after the function that originally create it has written. That means the function that is originally created that return, but in that time I can also use work with that, right? Thus interpret static as a way to say, okay, you can thus interpret static way as a way to say give me a own value, give me a own value, give me a reference that valid from um, give me a reference valid for entire duration of the program, okay. The first approach is how you solve the issue in this previous exercise, okay. Allocating new vector to hold the left and right part of the original vector which were move the spawner thread, okay. Static reference, okay. If we use static reference, what will happen? Okay, data segmentation, okay. Static, okay, here we can see see what no base heap, okay. Okay, here data we use static variable, okay. BSS segment, okay. Segment container, okay. So most common use case is references static data such as string liter. That means we use this as a in static data, right? Okay. Leaking data, so we let's say we just in previous model we just have those what we learned. Why static use? Because if we want a variable live as long as the whole system exists, then we can use static variable, and static variable are used in static data, right? So these two things the core learning about this part, static lifetime, okay. Static data, data is contained in static variable, sorry, okay, static data, right? Sorry, okay. Okay, right? Now leaking data, what we understand from this part, let's see. Leaking data. Mm, okay. So what is leaking data? So the main concurrent around passing reference to spooner thread is used after free bug, free after free use after free. Okay, that means the reference is to swap thread, passing reference to spooner thread is used after free. That means the core of thread is used after free. Sorry, use after free. Okay, that is the core of this part, right? Use after free. That is the core concept of thread. Okay, what we are doing here, that the main uh, concern around passing reference to spooner thread is used after free bugs, accessing data using pointer to memory region that is all that already feed or deallocated. If you have working with heap allocated data, you can avoid the issue by telling Rust that you will never um, 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 reclaim that memory. You choose to leak memory intentionally. This can be done, for example, using box leak. This can be done even if you choose to leak memory. That means if I want to intentionally uh, leak data, I can do it, right? So if you want to write heap allocated data, you avoid the issue by telling Rust that you will never reclaim the memory. Okay, that means I will say to Rust, hey Rust, you will never reclaim. Okay, you will never reclaim. Mhm. You will never reclaim memory. That means we are intentionally leaking the memory. Okay, in the box is a data type that is allocated in heap, right? So we are using box leak. Okay, okay, box leak for leaking data, right? Okay, leaking process scope. Okay, leaking is high level concept, right? In the first phase, I don't think so we will use leak, right? Because it will not beginners concept. It is high level concept. If we want to leak data, leaking data is dangerous. If you keep leaking memory, the eventually memory crash. That means, yeah, we can use leaking word keyword so that we permanently take memory from the operating system. Yeah, that is the core concept. So leaking data is a process that we can to use to avoid or reclaim the memory, heap memory, allocated data. we stop compiler to reclaim the memory. So yeah, we learn this part that heap allocate data is never reclaimed in this part. Okay. mm. scope scope thread, right? Okay, we have 14, right? Oh shit, scope and thread. So yeah, scope and thread, great. So I should I draw a let's say I already draw something in this for scope and thread. mm. No. mm. mm. Transmit, clone, share, clone, mutex. Okay. Access multiple threads. Okay. No, I think we don't have this scope part, or we don't cover scope part. That means we have lots of thing to learn this part, this in this. So basically you all know that scope means a box. Like a scope means I will try to draw, and this is a scope. This is a scope. Let's say this is a no, this is total architecture of our function, right? This is our function, this is the total function body, right? This is the total function body. Now let's say we have function x. This is okay, sorry. We have function x. This is function x. This is fn sorry, function x. This is function x, right? This is function x. Now sorry, okay, this is function x and this is function y. So scope means this is the main function, right? This is the main unfn function. This is the main function, right? fn sorry, fn, this is the main function, right? This is the main function, and we have two function in this in this scope. Now for this function, the scope is spread on this place, right? For this function, the scope is spread this place. Now if we write something in here, let's say v, and here z, the v variable can't be accessed from x to y. That means we can't use x here. right? So that means the function leave only uh, this area, right? When the area is done, or area has been passed out, when it came to this part, the all the things will go out of memory, right? The memory destroy all the things from this function. So now we have new function, that is y, and new variable, that is z. So that is the scope, right? That is the concept of scope. Okay. uh, so front scope, sorry. Okay. Scope. now the problem is now the problem is uh, scope. Now the problem is uh, in the thread here we it is little bit tricky. Let's say normally when we use this function, that is predictable, right? And we are not using any thread in here. But if we use thread, let's say we use thread in this function, and we say it will execute after 5 seconds, and this function is our main function. Let's say this is our main body, and if we go through this function, after this function exit from this after this function execute, we have this function which is waiting for 5 seconds, and this immediately execute because it have no waiting period. Now let's say it will go out of the scope, and let's say it now the problem is it has not execute, and it executed, and the main function will now the main function will execute if we don't use join. If we use join, then it will wait for our function. Now what is the difference in scope thread? Let's see. We can sidestep this issue by using scope thread. That means all the lifetime issue we discussed so far that have a common source, that is the spoonered thread can outlive its parents. That means the parents children will live after the parents die. Okay, children function will live after the parent die. So we can sidestep this issue by using spooner thread, right? How we modify this function so that my children will live longer than the parents. Okay, we are using scope thread. Okay, now let's check this out. Okay, let's find out. Here is 1 2 3. Okay, so we have a vector, and we find out the middle point. Now we are using scope. Okay, in the scope what we are doing that is what we are doing, that is first we use vector and spread the middle point. Here is the first half of um, vector v, that means we spread the first half, right? And here is the last half of the vector. So print ln, so here s okay, v clone, okay, that means we will have first half and second half of the vector. If I give much more word, let's say 4 5 6 7 8 9 44 55. Okay, if we give long things, what will happen? We are using scope, that means the parent will children will live longer, right? Okay, let's see whatever. Okay, okay, so here is the first term, second term. It is easy, but I think there will be, we are using function scope and sdt thread scope take closure as input. It will sign argument is scope instance. Scope spooner. Scope expose is scope expose a swap method, right? Like std thread and swap. All the thread swap use scope will automatically join when the scope end. If if we were translate the previous example, okay, okay, if we want to translate previous example, if we use join, what will we can find out? Let's see. Okay, let's see. What happened in this function after using join? Okay, cannot find variable. I had to write. Sorry. Okay, okay. Sorry. We didn't give header 1, header 2. Let a and d l one equal handle 1 and control x. Sorry, let d le 2 sorry, what std thread is ead thread csop pe p scope. Okay, so let's run it. So, okay, oh, 1 minute, what happened here? Okay, what happened? Okay, sorry. So we use this scope. Okay. Well, sorry, I think we have facing some issue. Okay, handle, and we have second spooner which will have okay expression closure. Okay, we'll pass this on this part, right? Okay. Non-negotiable number, sorry. Missing open. Main function unclosed. Okay, sorry, unclosed. Okay, what we are doing here, we take a spooner. Okay, sorry, I just okay, sorry, what I just did, I just take this double. Okay, if I delete this part, it will be okay, right? Sorry. Okay. What we are doing, we just deleting. Okay, main function unclosed. So what is we are doing here, that means what is going on here, small okay, now let's what is going on, add. Okay, the problem is spooner, sorry, scope spooner, right? We are using spooner or scope, spooner, right? We are not using scope this time. We are not using scope, right? Previously we used scope, and this time we won't use scope. Let's see what output we find out. So okay, I think we are facing some issues, syntax issue. Okay, sorry. Okay. Okay, right. Now let's check it out. Okay, time derivation. So what error we find, let's see. Closure may outlive the current function, but the borrow midpoint which is owned by current function. Okay, midpoint pointer is borrowed here. Okay, we borrowed here, and the function require argument type static. Okay, so here okay, so closure may outlive the current function, but the borrow v which owned by the current function which owned by the function. V is borrowed from here. Okay, V is borrowed from here. Function argument outlives static. So the error we find, that is outlive the, that means what type of error we find it, the could not compile program. Okay, so closure may outlive the current function. That means closure is outlived the current function. uh, okay, okay, right. So the borrow from the environment, the transaction example without compile, through the compiler would compile that we cannot use from our spooner thread, since its lifetime is not static. That is not an issue with thread scope. You can safely borrow from the environment. It will be in our example, b is created before the spooning point. It will only drop after scope return. At the same time, the thread spooner inside scope are uh, guaranteed to finish before the scope returned. So here we understand a core thing, that is we are facing this error, right? That is good thing, right? So okay, so we are facing this error, the error saying closure may outlive the current function, the borrow a meta point midpoint which owned by the function. I want more explanation from the AI. I w1 w and want REXPLANET. I want more explanation from this error. The error occurs when you try to use a closure at the borrow a local variable in a context where the closure may continue to exist after the function has owned. What does closure may outlive the current function? The closure is a piece of code that can store and call later. For example, thread spooner, it is a closure, right? Okay, the new thread will run the closure concurrently with the current thread. The spooner thread may still be running after the current function has returned. That means closure code will be execute after the function exists. The closure outlive the function stack. um, Rust may uh, guarantee that any data closure use invalid for a long as the closure might run. That means Rust guarantee that any data that and the closure use is valid for as long as the closure might be run. The closure try to reference the local variable midpoint. The okay, okay. Now I will share the code with this guy. Let's see what he give me. Okay, the code provide to compile an error about the closure borrow closures, the borrow v and midpoint. Let's break down why this happened and how to fix it. Okay, both the closure v midpoint from the surrounding the function take closure that must safely The static boundary means closure cannot borrow any data from the current stack that is because the spooner thread may outlive the current function if the function return while the thread are still running. Those borrow reference would become dangerous. That means if the function return while the thread is still running, those borrowed reference would become dangling, right? Mm-hmm. B is owned by the current function. Midpoint is a local size. The closure capture V as a reference and the midpoint by the reference mid refer. Thread spooner require closure to be static. That means own all the data or hold only static reference. Therefore the code is rejected because the closure could outlive the end midpoint. Why does thread spooner have this restriction? The spooner create a new OS thread that is return the why does the thermo has restriction? Create a new OS thread and run independently the new OS thread. Okay, on stack heap closure, you pass it pass the move on the thread stack. Okay, after running the function create has been completely returned if the closure were the local. Okay, runs time rust prevent here that time that compile time requiring closure static that can only contain one data reference for to live forever. How to fix this? We use move, right? Okay, transfer ownership. If you don't need fee the thread spooner you move from the that means we are moving the ownership from this from this to this to this, right? Middle point to this. We are okay, in this scope we move the ownership of these two path spin vector, leave the first half in the and move the second half okay. Midpoint move the first half and second half is moved in second half. Okay, so that means we are using when we use spooner, and if we don't use static then it will give us a error that is called this: the closure may outlive the current function. That means the example would not compile V cannot be used for our spooner thread. That means reference B is cannot use in our spooner thread because we can't change the ownership, right? Here we are changing the ownership. Now I will show you how we are changing the ownership. Let's say we use, if we don't use this, do you think anything will happen? What do you think? If we don't use this variable part, what will happen? Okay, yeah, we don't. Okay, let's say we don't use this. Let's say what happened. Okay, now we have found this. mm, okay, let's see what's happened. mm, mm, Argument leave. Let's say we don't give any argument here, we will just print it. So do you think any problem will occur? Do you think any problem will occur? Yeah, in 30, yes, it will compile, right? It will compile. Here you can see it will compile first half of, second half of, and we get all the element. But when we want to shift the borrow, when we change the ownership, when we try to change the ownership in this part, with this line of code, when we try to change the ownership, we have to have use move, move, so that we can use that ownership, right? Sorry. V, and we run the sorry, fast, that will be fast. Sorry, here. Okay, let's see what happened. Okay, here you can see we can use move, but sorry, but error happened. Okay, because our borrow has been moved, now we can't use this on this print line, right? So the moral of the story is what we learn: if we use scope spooner, then we can use uh, um, after the code execute, we can use the variable, right? We can use this variable after the execution of this code. But if we don't, then then what will happen? If we use scope, then we can we in this part we can call, and the ownership won't move, right? But if we don't use scope in that time, or spooner, we use spooner in that time, we will face a problem that that will give us a closure closure has been moved, this type of error, right? So what we just learn today, we just learn four things, because this is hard topic in Rust. I think it is enough for today. We should we will do this topic in the next day. Hopefully you guys um, will go through with me, and I will, let's say, Excel drawing, Excel drawing, AXCACALD, Excel draw. Okay. Here you can see I will give you, sorry, I will provide, okay, copy, control V. Okay, I will provide you this link, right? I will provide you this link. You can check this out, what we just learned. So yeah, thank you everyone to watch, and hopefully we can learn Rust and we can land a job, right? So tata, bye bye.